This is SpaceTime Series 27, Episode 99, for broadcast on the 16th of August 2024. Coming up on SpaceTime, current ideas on how Earth's continents formed just got a whole lot muddier, a major breakthrough in subatomic particle measurements, and studying the cosmic dawn and the ultimate fate of our universe. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The formation of Earth's continents billions of years ago helped set the stage for the formation and eventual evolution of life on this planet. But scientists have long disagreed on exactly how those land masses formed and whether it's through the same sort of geological processes we see today. Now, a new study by David Hernandez-Arriba from the University of Illinois adds new information to the debate, poking holes in the leading theories of continental formation. Hernandez-Arriba used computer models to study the formation of magmas thought to hold clues about the origins of the continents. His work, reported in the journal Nature Geoscience, looked for magmas that matched the compositional signature of rare mineral deposits called zircons that date back to the Archean period between 2.5 and 4 billion years ago. That's the time most scientists think the first continents formed. Last year, scientists from Australia and China published a paper arguing that Archean zircons could only be formed by subduction. That's when two tectonic plates collide, one subducting under the other and pushing the lighter material, the landmass, up to the surface. Now that process still happens today, causing earthquakes and volcanic eruptions and reshaping the coastlines of continents. But Hernandez-Arriba claims subduction wasn't necessary to create the Archean zircons. Instead, he found that the minerals could also form through the high pressures and temperatures associated with the melting of Earth's thick primordial crust. He says that his calculations and models are producing the same signatures for zircons and even provide a better match through the partial melting of the bottom of the crust. Now, if correct, it means that based on these results, scientists still don't have enough evidence to say exactly which process first began forming continents. Now, these results also raise uncertainty about when plate tectonics would have started on Earth. If Earth's first continents were formed by subduction, that meant that the continents started moving between 3.6 and 4 billion years ago, which is as little as 500 million years after the planet first formed. But the alternative theory of melting crust forming the first continents means that subduction and tectonics could have started much later. The thing is, as far as we know, Earth's the only planet in our solar system to have active plate tectonics. And that's important because how the first continents moved controlled the planet's weather. It also controlled the chemistry of the oceans, and all that was important for the formation and evolution of life as we know it. This is SpaceTime. Still to come, a major breakthrough in subatomic particle measurements, and a new space telescope to study the cosmic dawn and the ultimate fate of our universe. All that and more coming up on SpaceTime. Physicists at CERN have achieved the first ever direct observations of high-energy electron and muon neutrino interactions in a particle accelerator. Neutrinos are elementary subatomic particles. They're fundamental to the standard model of particle physics, the foundation stone of science's understanding of the universe. Neutrinos are generated through radioactive decay in stars, in supernovae, in nuclear explosions, in particle accelerators and atomic reactors. They're so named because they're electrically neutral, and because their rest mass is so small, it was long thought to be zero. Neutrinos are the most common form of matter in our universe. And because they have almost no mass, they're capable of being accelerated to almost the speed of light. Neutrinos come in three known types or flavors: electron neutrinos, muon neutrinos, and tau neutrinos. Each of these have their own specific properties. Confusingly, however, the three flavors of neutrinos don't line up with their three rest masses. It seems that each of the three flavors is made up of a quantum mixture of the three mass species. So a particular tau neutrino, for example, has bits of both electron and muon neutrinos in it. And because of these different mass species, it allows neutrinos to oscillate between the three flavors. For example, an electron neutrino produced in a beta decay reaction could well end up interacting in a distant detector as a muon or tau neutrino. The other amazing thing about neutrinos is that they interact with matter only through gravity and the weak nuclear force. In fact, they're so weakly interactive, right now there are several trillion neutrinos passing through you and you don't even notice them. They're important for answering fundamental questions about the universe, including why particles have mass and why there's more matter than antimatter in our universe. So understanding their rare interactions with matter is crucial for obtaining a more complete picture of particle physics and consequently a better understanding of the universe. Now, so far most neutrinos studied by researchers have all been relatively low energy ones. To date, neutrino interaction cross-sections, which is the probability of a neutrino interacting with a target particle, have not been measured at energies above 300 gigaelectron volts for an electron neutrino and between 400 gigaelectron volts and 6 teraelectron volts for a muon neutrino. But all that has now changed. In a groundbreaking study reported in the journal Physical Review Letters, physicists led by Akitaka Araga from Chiba University in Japan have utilized the FASA forward search experiment at CERN's Large Hadron Collider to achieve the first ever direct observation of high-energy electron and muon neutrino interactions in a particle collider. One of the primary objectives of FASA is to study the high-energy neutrinos produced by the Large Hadron Collider's proton-proton collisions using the dedicated FASA-V detector. Akitaka Riga says charged particle tracks produced by neutrino interactions in the detector can be reconstructed with submicron precision, allowing scientists to identify electron and muon charge current neutrino interactions and the measurement of neutrino interaction cross-sections in the currently unexplored tera-electron volt energy range. The FASA-V emulsion detector is made up of 730 layers of interleaved tungsten plates and emulsion films with a total mass of just over a ton. The team analysed just a subset from the exposed detector volume corresponding to a mass of just 128.6 kilograms, looking for high-energy neutrinos from the Large Hadron Collider collisions. And after applying strict criteria, selecting events with electrons and muons with energies above 200 gigaelectron volts, 4 electron-neutrino interaction candidate events and 8 muon-neutrino interaction candidate events were observed. These interactions had a high statistical significance of 5.2 sigma for the electron neutrinos and 5.7 sigma for muon neutrinos. Now, in physics, anything above 5 sigma is considered a real discovery. In other words, it's extremely unlikely to be just random background fluctuations, and therefore they represent actual neutrinos. The neutrinos detected in this study had energies in the tera-electron volt range, the highest ever detected from an artificial source. This marks the first ever measurement of neutrino interaction cross-sections in the unexplored energy range of 560 to 1,740 gigaelectron volts for an electron neutrino and 520 to 1,760 gigaelectron volts for a muon neutrino. Importantly, the measured interaction cross-sections are consistent with predictions in the standard model. So these results are marking the first ever physics results on neutrinos from a particle collider. That's a breakthrough in particle physics that could revolutionize the strategy of large-scale experimental research in this field. This is SpaceTime. Still to come, studying the cosmic dawn and the ultimate fate of our universe using a new spacecraft. And later in the science report, the World Health Organization issues a new warning about a new type of superbug threat. All that and more still to come on SpaceTime. As America's intelligence agencies continue to improve their designs for ever newer generations of spy satellites, older reconnaissance and surveillance spacecraft designs are becoming superseded. And so it was in 2012 when the National Reconnaissance Office gave NASA 2 spare spy satellites for repurposing into space telescopes, each potentially more powerful than the agency's famous Hubble Space Telescope. For years, it had been an open secret in the astronomy community that the school bus-sized Hubble was simply a modified keyhole spy satellite, redesigned and fitted out to point upwards into space rather than downwards onto the planet's surface. Hubble even shares the same 2.4-metre primary mirror and 30.5-centimetre wide secondary mirror dimensions as used by Keyhole, but with a longer focal length and hence a narrow field of view. And much of its communications, navigation and manoeuvring systems are also exactly the same as that used by Keyhole. The two gifted Keyhole spy satellites gave NASA the opportunity to develop a new Earth-orbiting wide-field telescope specifically designed to search for signs of a mysterious force called dark energy, which is responsible for the accelerating expansion of our universe. Understanding dark energy will allow scientists to determine nothing less than the ultimate fate of the cosmos. Will the expansion of the universe eventually slow down, with gravity taking over and causing everything to start to come together again, sort of a big crunch? Or will dark energy eventually peter out, allowing the universe's expansion to stop and turning the cosmos into a steady state? Or will that accelerating expansion continue forever, eventually resulting in stars and galaxies being so far away from each other, the sky is just a cold, dark, empty place? Work on the new probe, which has been named the Nancy Grace Roman Space Telescope, has now been underway for about a decade, with scientists looking at a launch date of May 2027 aboard a SpaceX Falcon Heavy rocket. Originally named the Wide Field Infrared Survey Telescope, or WFIRST, it was renamed in honor of Nancy Grace Roman, a Jewish-American astronomer who made important contributions to stellar classification and motions. She was the first female executive at NASA, serving as the agency's first chief of astronomy throughout the 1960s and 1970s. The telescope's development has been primarily handled by NASA's Goddard Space Flight Center in Greenbelt, Maryland, with participation by the Jet Propulsion Laboratory in Pasadena, California. Like the Webb Space Telescope, Roman will be looking at the universe using infrared eyes, and again like Webb, it'll be placed in orbit around the Lagrangian L2 point, 1.5 million kilometres away on the nighttime side of the Earth. However, while Webb's designed to operate in a very narrow and detailed field of view, the Nancy Grace Roman will cover a very broad patch of the sky. Roman's mirror gives the telescope a 0.281 degree field of view. The light from the telescope will enter two main instruments, the Wide Field Instrument and the telescope's chronograph instrument. Roman will measure the light from over 1 billion galaxies over 5.5 years, giving astronomers an unprecedented number of galaxies in its field of view, as well as the distribution of those galaxies across the universe. These will include galaxies that current ground-based telescopes are missing, and that will allow astronomers to better understand the effects of dark energy on large cosmological scales, looking at the clustering and evolution of galaxies. Now, because of these characteristics, it'll also observe a large number of Type 1a supernovae. These mark the explosive deaths of a specific type of star that led to the concept of dark energy and the accelerated expansion of the universe in the first place. Type 1a supernovae are caused by the death of stars in a specific mass range. And because they're roughly all the same, they explode with roughly the same level of luminosity. And that allows astronomers to determine how far away they are by judging their apparent brightness using what's known as the inverse square law. It's like looking down the road at a row of streetlights. The further away the streetlights are, the dimmer they appear, even though you know they all have exactly the same level of luminosity. The telescope's unique design will allow it to probe the chronology of the universe and the growth of cosmic structure, with the end goal of measuring the effects of dark energy, the consistency of general relativity, and the curvature of the very fabric of space-time. These characteristics mean it'll also be able to search for extrasolar planets using gravitational microlensing, the bending of light by the effect mass has on the curvature of space-time. This report by NASA TV.
Is there life out there? Are we alone? One NASA instrument will get us closer to finding answers to some of humanity's biggest questions. NASA's Nancy Grace Roman Space Telescope will fly with an instrument on board called a coronagraph that will allow scientists to see exoplanets, or worlds beyond our solar system, like never before.
So a coronagraph is a camera or an instrument that we use to look at planets around other stars. And the reason we need a special instrument to do this is because stars are so much brighter than planets. And what we need to do is we need to put something in front of the star to block the light from the star so that we can instead see the very faint light coming from the planet.
The Roman coronagraph, built at NASA's Jet Propulsion Lab, will take a giant leap forward in our ability to see worlds beyond our solar system, and will observe larger exoplanets, roughly the size of Jupiter. Testing the technology to see these planets is the stepping stone toward one day capturing direct images of Earth-like planets around Sun-like stars. These technologies include different specially designed masks and self-flexing mirrors that will work together to block starlight, making planets orbiting these stars observable. Testing technologies that could enable future missions like NASA's Habitable Worlds Observatory mission concept.
And one of the primary goals for the Habitable Worlds Observatory will be to use a coronagraph using the technology that we demonstrate in the Roman coronagraph to look for signs of life around Earth-like planets orbiting Sun-like stars. If we show that these technologies work together well, we will have demonstrated about 1,000 times better performance of a coronagraph in blocking starlight and allowing planet light to come through than any coronagraph ever built.
As it embarks on its journey to the stars aboard NASA's Nancy Grace Roman Space Telescope, the Roman coronagraph instrument will pave the way for future searches for habitable worlds and ultimately, the search for life beyond Earth.
And in that report from NASA TV, we heard from Roman chronograph instrument technologist Vanessa Bailey and Roman chronograph deputy project scientist Jason Rhodes. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. The World Health Organization has issued a warning about a new superbug called hypervirulent Klebsiella pneumonia sequence type 23, which has been reported in all 6 World Health Organization regions, including Australia. The superbug is resistant to all last-line antibiotics and can cause severe infections, even in healthy people. Now, the WHO has assessed the risk as moderate, given the challenges with surveillance, a lack of information on laboratory testing rates, track and scale of community transmission, the gap in the available data on infections, hospitalization, and the overall burden of the disease. WHO is recommending that all countries increase their laboratory diagnostic capabilities to allow for the early and reliable identification of this new threat. Well, in case you haven't noticed it, planet Earth is currently going through its 6th mass extinction event, and this one is caused by human activity. A report in the Journal of the Frontiers of Science says researchers have now identified 16,825 sites around the world which should be targeted to help prevent the worst effects of the Anthropocene mass extinction, which is already wiping out species at an ever-accelerating rate. A look at the areas of the world scientists should be targeting, the authors mapped the entire world using biodiversity data to find areas currently unprotected by conservation efforts that house large amounts of rare and threatened species. They say the sites they've identified covered 1.22% of the world's landmass, and proper protection of these sites would help preserve some of the world's remaining rare and endangered species. A new study has concluded that the so-called screaming woman mummy may well have died in agony. A report in the journal Frontiers of Medicine used state-of-the-art techniques to virtually dissect the 3,500-year-old New Kingdom female corpse known as the screaming mummy because of her remarkable open-mouthed expression. That, combined with the presence of organs, which are normally removed during the mummification process, initially led researchers to believe that her mouth was open due to careless embalmers neglecting to close it. However, the team found that she had been embalmed correctly using costly imported frankincense and juniper, and her hair had been dyed, and a wig had been made and placed on her head, potentially ruling out carelessness. There was no obvious cause of death, but researchers say the mummy's open-mouthed expression may be due to cadavic spasm, which is typically associated with dying in considerable pain and under strong emotions. In what could be the biggest crisis facing the world of the paranormal today, there are now growing reports that the United Kingdom is running out of ghosts. Authorities in such things fear spirits have either become dormant or have moved on to the other side. Tim Mendham from Australian Skeptics says at least one scientist believes he has the answer.
This is shock, horror, panic information, right? This is really sad that it looks like the UK ghost population is decreasing, which is a major concern for all other ghosts, I dare say, but certainly ghost watchers. Various suggestions. They're either dying off, which I thought ghosts already were, or they're running out of energy and they need a boost. They need to be plugged into a power point in the wall to get a boost to their energy level. So it's like the paranormal version of an electric vehicle. So that, they need the energy boosts. Well, they've just passed over to the other side. They've had enough of hanging around sort of pubs and old buildings and things, and have finally moved on and have settled down for a nice deck chair in heaven. But it's a suggestion by a fellow who's has a PhD in nuclear physics. What?
After the University of Wollongong, I don't think PhD mean terrible.
It's a sad thing that he is suggesting that ghosts are running out, and he's asked people about their ghost hauntings, etc. And even some supposedly highly haunted places haven't experienced anything as much or anything at all in the last few years. This crops up occasionally. This fellow's theory was that they need an energy boost, and because he's in nuclear physics, I don't think it's plugging a ghost into a nuclear power plant is going to help that much.
Is he being serious, or is he just...
How can you tell? He goes on about it a bit, actually, so you tend to think maybe there is something that he's sincere about it. You can find a PhD to be sincere about any sort of nonsense.
Who was that famous UFO enthusiast who had a PhD? Stanton Freeman.
Stanton Freeman. It's also called the Nobel syndrome, or what we call the Nobel rot, that a lot of Nobel Prize winners move off into other areas beyond their actual award-winning discipline, and they go sideways into something else that they have no qualifications for. But because they've won a Nobel Prize, everyone thinks, well, they must know what they're talking about. Well, they don't. It's a common phenomenon of academics and things that going into other areas. It happens a lot, unfortunately. We've had physicists who talk about ghosts. Actually, that's probably closer than a nuclear physics person talking about ghosts disappearing. But it's not that uncommon. It's depressing. It's interesting that a lot of the alternative belief industry says, well, science doesn't know what it's talking about, so here's my scientist explaining what it really is. You can't have it both ways. So that happens a lot too. So whether this guy is serious or not, it's hard to say. Whether spirits are really disappearing, I don't know. Maybe people are getting sick of them. These things come in waves. It wasn't that long ago that someone was saying Loch Ness Monster was definitely finished because in the last 12 months we hadn't had any recent sightings. Well, they're back. You got more sightings. You get more sightings that go. Same things happen with the UFOs. It goes in spurts. Everyone thinks, oh my God, it's all over, and then a few years later it comes back. So these are the things you take with a grain of salt and throw the salt over your shoulder to make sure there's no ghost behind you.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.